Much of the data we work with in GIS begins as human language. For example, a social media post might say, "Power is out across New York City," or "I'm stuck in Times Square," or "Flooding reported in NYC." A human reader immediately understands that these messages refer to places, but a computer doesn't. Before GIS tools can map this information, the text needs to be interpreted so that the words referring to places can be identified. The process of converting language to data is commonly described as natural language processing, or NLP. In this context, NLP does not mean understanding grammar, emotion, or intent. It simply means asking a computer to scan text and identify which words refer to places. In NLP terminology, the things in the text are called entities, and the task of finding them is called entity extraction. Entities can be people, organization, or places, but here we focus only on place entities. When NLP tools identify places, they often label them using short codes. One common label is GPE, which stands for Geopolitical Entity. GPEs include countries, cities, and administrative regions such as the United States, New York City, or Brooklyn. Another label you might see is LOC, which refers to locations that are not political units, such as downtown, the coast, or the east side. A third label is FAC, which refers to facilities like airports, bridges, and hospitals, for example, JFK Airport or the Brooklyn Bridge. GPEs are easier to match to known geographic boundaries, while LOC and FAC are often vague and ambiguous. There are multiple ways to extract place entities from text. The simplest approach is a rule-based extraction using a gazetteer. A gazetteer is just a list of places. The computer checks whether any words in the text match the list of places. If a post contains a word like New York City and that name appears in the gazetteer, it is extracted as a place name. This method is transparent and easy to understand, but you can only find places that are already included in the list. Another approach uses pre-trained NLP models that have learned patterns from large collections of text. Instead of matching to a fixed list, these models examine how words appear in context and decide whether a word or phrase is likely to be a place. Using the same examples, a model may label NYC, New York, or Times Square as place entities, even if those exact strings were not explicitly listed beforehand. This approach can find more place references, but it is harder to explain exactly why the model made a particular decision. In practice, many systems combine gazetteer modeling approaches. At the end of the NLP step, we still do not have geographic data in the GIS sense. What we have are place names as text strings, such as New York City, NYC, or Times Square. In order to get place names on a map, we use geocoding to represent places on the Earth's surface.